Alright guys, so today we're going to talk about solubility. And this is what our lab was over, so just remember we have two things that we need to talk about. With solubility, we have soluble, then insoluble. So soluble is when things, I'm going to use, hold on, or I'm going to use this over here as a blank spot. So soluble is when a precipitate, or when no solid forms. And insoluble is when solid forms. Alright, so, I completely missed my spot. Alright, so soluble is when no solid forms, where insoluble is when the solid forms. So, using our solubility rules that we should have found in our lab, but also we have right here. Remember, this is a STAR reference sheet. This is at the very top of your Google Classroom. We have rules where things are soluble or where things are insoluble. So, soluble things. So, we have things that are insoluble and things that are soluble. We have two different sections. What I always like to do is I always just use what are solubles. Because if they're soluble, that means you can tell what's insoluble or not. So I always look at the soluble, and again, you'll notice that really our exceptions are our halogens. So halogens and also sulfate, which you should have seen a lot in the lab, which I believe we did as well. I think most of you, the results I saw showed this as well. And then we have our insolubles, and again, if it's not on our soluble list, it's going to be insoluble. So, I'm going to do two problems for you. I'm going to do one where I have to make the equation, and one where I do one that's already given for you. So we want to do predict the possible products with these with the phase labels. So we want to make sure we put solid, liquid, aqueous, all that stuff. And then we need to balance the chemical equation, and also if there's no visible action occur, we have to write NR off to the side. And if a precipitate forms, we have to give the formula the name. So I saw this a lot on the test. Make sure you answer all of the questions. So we have a solution of iron sulfate, iron 2 sulfate, and barium hydroxide. So that's our solution. So iron we know is Fe. We don't know the charge necessarily. Oh, wait, yes we do. Fe2 plus. Sulfate is 2 minus, so we get iron sulfate, because our charges cancel out, plus barium. Actually, hold on. I'm going to write this stuff up here. Sorry, guys. Iron, barium. So we have iron is Fe2 plus. Sulfate is SO4 minus 2 minus. Then barium, based off the periodic table, we have a 2 plus. And hydroxide is OH minus. Again, if you don't know where I'm getting those, I am either getting them off the periodic table or I'll probably challenge. So hydroxide, OH minus. I think we had sulfate, SO4 2 minus. So we have our charges. So we have iron. Fe, FeSO4, and again we have to include our insolubility rules. So sulfates are soluble except when we have compounds Sr, Ba, Pb, or Hg. We have iron sulfate, so that is not one of our exceptions, so it's going to be aqueous. So soluble means it's going to be aqueous. Plus, we have barium hydroxide. That is BaOH2. Again, I got the 2 by looking at the charges. 2 plus, 1 minus, so I need 2 hydroxides to cancel out that 2 plus. Again, we have hydroxide. Hydroxides, again, in our soluble, or insoluble, but compounds of NH plus, the alkaline metal cations, Ca, Sr, and barium 2 plus. So that means it's soluble. So sometimes you have to look at the others, but most of the times you don't. So aqueous. And I will tell you for a hint, all of these, I believe all of the first ones are going to be insoluble or soluble. So all of them should be aqueous. So now we have to go ahead and do our switch. So again, it's a double displacement. So we are going to switch our Fe and our Ba. And remember, the charges come along with it. So when I switch my Ba, it has a charge of 2 plus, and it's going to sulfate, which has a charge of 2 minus. So we're going to get BaSO4. Refer to our chart. So sulfate, it's soluble compounds except for compounds that are Sr2+, Ba2+, Pb, and Hg. So we have Ba2+, so that makes it insoluble. So it's going to be a solid. Then our other one, we're swapping iron and OH. So we have Fe2. So we have, let me do it yellow because I think it shows up. So we have Fe2 plus and OH1 minus. So we're going to get, or I'll do it in yellow too. Fe OH2, because again we need we need two OHs to cancel out our Fe2 plus. Alright, so am I done? No, I shouldn't be. Sorry, let me scoot this over. Because it tells me I need to balance my equation, and I also need to write, if a precipitate forms, write the name of the precipitant. So I'm going to quickly balance the equation. I'm going to start with one of the OHs. I think this is 1. So Ba is 1, OH2, 1. Cool, easy balancing. And then what is my soluble? It is this BaSO4. So I am going right off to the side, BaSO4. Because it told me in my question, if a precipitate form gives the formula and name of the precipitate, so I guess I need to do the name too. So that, which is barium sulfate. Barium sulfates. Alright, and now I've answered all of the questions, so now I can move on. So I'm going to jump ahead to one of these down below. I have Na2S plus zinc SO4. So again, I always like to start off, write your charges down. So I have Na plus, which I found on the periodic table. I have S2 minus, again found on the periodic table. And then I have zinc, I don't know necessarily, and SO4. So I look at sulfate, and sulfate has a 2 minus. Notice it only has 1 right here. They cancel out, so that means sulfate's going to be 2 minus, and zinc's going to be 2 plus. So always find your anion charge, because that will determine your cation if it's not on the periodic table. Alright, then we know it's a double displacement reaction, so we are going to go in, potentially, we're going to go in and switch up. So again, I am going to do sodium a plus, and sulfate is a 2 minus, so that means I'm going to get, let me write this a little bit farther away, Na2SO4. Again, check your solubility rules. Sulfate, it says it's insoluble except with Sr2+, Ba2+, Pb, and Hg2+. I don't have any of those, so that means it's soluble. That means it's going to be aqueous. Plus. Alright, I have S2 minus, zinc. So that's going to be zinc S, because the charges cancel out. Alright, and down here I have S2s, compounds. It's insoluble, except for compounds that are NH4, alkali metals, Ca, Sr, Ba. I don't have any of those, so that means it is going to be soluble. Alright, next we're going to balance our equation. So I have one of these. I think it's all 1, 1, 1 again. Really doing a lot for balancing. today. Yeah, that's all 111. All right, and my precipitant was this one right here, so I'm going to do zinc S, and that is zinc sulfide. So it's not 8. If I could spell it right, that would help. Sulfide. So it's not H or I, it's I because it's not a polyatomic. Alright, but there's 2 practice problems for you. You are in charge of finishing the rest of this. I think it's only, what, 12 more problems? Nope, 10 more problems. Perfect. Alright, but you guys are doing great. If you are having trouble, make sure you email me.